All right, lesson 1-2 was understand rational numbers. So the objective for today was to be able to identify irrational numbers. So for example 1, they had a Venn diagram that shows the relationship among rational numbers. So you may have seen a Venn diagram like this before, where you have your rational numbers, and your rational numbers are made up of fractions, positive and negative, decimals that end, that terminate, that repeat, and then you have your integers. Those are your positive and negative whole numbers. You have your whole numbers, which are your 0 and then positive numbers, so 0, 1, 2, 3, 4, and so on, and then your natural numbers, which is your 1, 2, 3, 4, basically your accounting numbers. So looking at this Venn diagram, how would you classify the number 0.247583326 ... Now looking at these, it doesn't really match any of these categories. I'm looking at the numbers that are in them, and there's none that really look anything like this. And that's because this is what's called an irrational number. So numbers that are not rational are called irrational. So an irrational number is a number that cannot be written in the form AB, where A and B are integers and B does not equal 0. So essentially what that is saying is that you cannot write it as a fraction. So we have a little extension to our Venn diagram, and those are all of your irrational numbers that are not included in this Venn diagram. Those are your non-repeating, non-terminating decimals. And what that means is if I have, for example, 0.5 repeating, that would be considered a rational number. Even though it goes on forever, it's not non-terminating, it's still repeating, so that's considered rational. But any number that does not repeat and does not end is considered an irrational number. Example 2, identify square roots as irrational numbers. Okay, so they want us to classify the square root of 3. So just to kind of review, the square root of a number is a number that when multiplied by itself equals the original number. So for example, the square root of 2 times the square root of 2, when I do that I get 2. Okay, these square roots, I get the square root of 4, and that gives me 2. Then you have something that's called a perfect square. Those are your numbers that is the square of an integer. So the first 3 integer perfect squares are 1, 4, and 9. So when I take the square root of 1, I get 1, because 1 times itself equals 1. When I take the square root of 4, I get 2. The square root of 4 is 2 times 2, so 2. And then the third perfect square is 9. When I take the square root of 9, I get 3. So 1, 4, and 9 are your perfect squares. Now if you look at the square root of 3, that's going to fall somewhere in between the square root of 1 and the square root of 3. And since you cannot write the square root of 3 as an integer, because 1 squared and 2 squared are 1 and 4, and it has to be somewhere in the middle, this is what's going to be called an irrational number. So we are going to, I can't spell, we are going to classify this as an irrational number. Okay. Example 3. Classify numbers as rational or irrational. So we're going to take these 4 numbers and we're going to fit them into either the rational classification or the irrational. So looking at this first one, we have negative 81,572. It's a negative number, so that would be considered an integer, and integers fall under your rational numbers, so we're going to put negative 81,572 in the rational category. Okay? I can also think about that one as I can write it as a fraction. I can put it over 1, and that is writing it as a fraction, which was one of the things that rational numbers have to be able to do. The square root of 11. 11 is not a perfect square, so that is going to be an irrational number. 5.63633333. This number, it does not end, so it's non-terminating, and it's non-repeating. It has a pattern here, but it's not repeating, meaning it's not going 63636363. So because of that, this is going to be considered an irrational number. And finally, the square root of 16. This is a perfect square. It's 4. And since this can be written as a rational number or a whole number or an integer, the square root of 16 is going to be rational. And that's how you classify rational and irrational numbers.